Okay, so I said multiply and reduce, but really you can reduce then multiply, right? So if you multiplied first, that's okay, but recall that we're allowed to reduce if there's a common factor in the numerator and the denominator. Okay, so for example, we know that 4 is 2 times 2, right? So we could reduce a common factor of 2 from both the numerator and the denominator. Okay, and then 6 can be rewritten as 2 times 3. Okay, so you can reduce a 3 from both numerator and denominator. Okay, so now you can't reduce these matching 2's because they're both in the denominator. Okay, so up top, there's nothing left. Technically, it's invisible 1 times invisible 1. Okay, so 1/4. Okay, so if you had just multiplied right away, then you would just have to reduce at the end. Okay, so of course you get the same answer, but the numbers are a lot smaller if you reduce first. Okay, so for this problem, it's not a big deal, right? 6 times 4, you can do that. But when you look at, some of the problems we have coming up, like I personally don't really want to multiply these together, right? So we'll see that reducing first will be very, very beneficial. Okay, but let's finish the warm-up section first. We also want to recall that an integer can be turned into a fraction by putting it over 1. So this time, no reducing is possible, so you just multiply straight across, numerator times numerator, denominator times denominator. Okay, over here, let's see. You can reduce in different ways, right? Like this 6, you can either reduce it with the 3 or with the 4. In the end, it'll end up the same. I'll do 20 is 4 times 5, so I can get rid of these 4's. Then 6 is 2 times 3, so I can get rid of these 3's. So that leaves me with 5 times 2 is 10, times 7 is 70. Okay, over here, the 2's can cancel out, the 3's can cancel out, the 4's can cancel out, so just 1/7. Okay, and then we want to remember that to divide, we would typically rewrite it as multiplication by reciprocal of the second number. So you leave the first fraction alone, but then to change the division to multiplication, you do the reciprocal. You flip the fraction upside down. Okay, so 14 is 2 times 7, so we can get rid of a 7 from each section. But also, 6 is 2 times 3, so get rid of a 2 from each section. Okay, so we get 3/1, which is just 3. Okay, 1/12 stays the same. 5 is originally 5/1, so the reciprocal is 1/5. This time you can't reduce, so you just multiply. Over here, 4 is 4/1. Keep that the same. Multiply by the reciprocal, 9/2. 4 and 2, or 4 is 2 times 2, so get rid of a 2 from each section. And then lastly, 5 divided by 3. I can turn them both into fractions, keep the first one the same, do the reciprocal of the other one. Okay, so again, you'll see that when we aren't just dealing with constants, when we're dealing with variables, polynomials, even though there's letters involved, the basic process is the same, right? So again, you reduce, you multiply straight across. For multiplying, for dividing, you do the reciprocal, you rewrite as multiplication, but again, same thing, you reduce, you go straight across. Okay, so let's go ahead and start with multiplication. Okay, so these are going to be the sort of the steps we do in order. Okay, so step 1, factor each, numerator and denominator separately. So I mentioned that factoring is still a really important skill, maybe even more important than what was in Unit 1, because here you may need to factor multiple times per problem. Every single numerator, every single denominator, it's beneficial to have them in factored form. Okay, second step. Check all denominators for EVs, which recall means excluded values. Okay, and remember, you only need to check the denominators because it's okay if the numerator turns into 0. It's only the denominator that cannot be turned into 0. Okay, third step. Reduce common factors. Okay, so I'm not going to write this, but recall that you can only reduce if it's in both the numerator and the denominator, as we saw in, sorry, where was it? Oh, the very first problem. All right, so if you have a common factor both in the denominator or both in the numerator, you can't reduce them, they combine, right? You can only reduce if it's one up top and one on bottom. Okay, and so the very last step in a multiplication problem is to actually multiply. Okay, so again, students are always very eager to dive into things. They want to multiply right away. That is not the most efficient way of doing things. So please follow this order of steps. It'll help you out. Okay, so let's go ahead and see how this works. Let's actually jump over and do letter B first. Okay, so step 1, factor each numerator and denominator separately. Okay, so I'm just going to redraw the fraction. So factoring this numerator, I know that it's a trinomial, right? So it's going to turn into 2 parentheses. X squared has to come from x times x. The negative last term means there's 1 positive and 1 negative. Okay, these two numbers multiply to 2, but is it positive 1, negative 2, or positive 2, negative 1? Well, the middle term is positive, so I need the positive number to be bigger. So positive 2 and negative 1. Okay, now the denominator of this first rational function is already 1x to the invisible first power. There's no factoring possible, so you can just keep it the same. Just to help visualize things, though, I'm just going to wrap it in parentheses. Okay, so now I'm going to factor the second rational function. Again, a trinomial. Don't forget, always check for GCF, but there isn't one. Okay, so x squared comes from x times x. Again, the negative c value means it must be 1 positive times 1 negative. This time the numbers multiply to 3. So it's either positive 1, negative 3, positive 3, negative 1. The middle term is positive, so I want the positive number to be bigger. So positive 3 and negative 1. Okay, then denominator x plus 2 is, again, already fully factored. Okay, so that's step 1, right? I factored each numerator and denominator separately. Okay, step 2, check all denominators for excluded values. Okay, so this denominator over here, right? I need to know where does this denominator become 0. Okay, so this denominator becomes 0 if x is negative 3. I also check this denominator. Okay, I get x equals negative 2. Okay, so those are the EVs for this problem. X cannot be negative 3, it can also not be negative 2. Okay, moving on to step 3, reduce any common factors. Okay, so because it's in factored form, we know each of these parentheses multiplies all other parentheses. So this x plus 2, it is multiplying the rest of the numerator. Okay, so this x plus 2 is a factor, and this x plus 2 multiplies the rest of the denominator. Okay, so we do have matching x plus 2 factors, so we are allowed to reduce those away. Okay, I also noticed we've got these x plus 3s. Okay, so this denominator x plus 3 is the whole denominator. And this x plus 3, it does multiply over here, and it does multiply over here. So it is a factor of the whole numerator. Okay, so we are allowed to reduce the x plus 3s. Now these x minus 1s, although they're both x minus 1s, they're both in the numerator. So we're not allowed to reduce them. Okay, so there's nothing left in the denominator. We don't need to write an invisible 1. That would be if it's the numerator. Okay, so the only things left are parentheses x times 1, x minus 1 times parentheses x minus 1. So x minus 1 squared is fine. Okay, so if you did not factor first, if you jump straight into the multiplication, you would be doing, okay, this is x to the 4th, this is plus 2x cubed, this is minus 3x squared, and then you have to do 9 total multiplications, and you're left with an x to the 4th, which we don't want to work with. Okay, so again, don't jump straight into multiplying. Make sure you factor first. Okay, but also make sure that you do the excluded values before you reduce, right? Because if you reduce first and you're left with this, you say, oh, there's no denominator, which means there's no excluded values, right? But there were. Okay, so always check for excluded values before you reduce. That's going to be a theme for the whole unit. Okay, so any questions on this first example? Okay, so let's go back to letter A now. Okay, so this one, again, factor if possible. This is a monomial, right? This is a binomial, but it's already 1x to the first power. Okay, and these are both monomials. Okay, so I won't do anything for now. Okay, next step, check for EVs in all denominators. Okay, so 5x squared, wrong color, sorry. Okay, so where can that equal 0? Okay, so if x is 0, then 5x squared as a whole turns into 0. And what about the other denominator? Where does 2x cubed turn into 0? Also at 0. Okay, so excluded values do not have like multiplicity. It's not like roots. Okay, so you don't say like x cannot be 0, multiplicity 2. You don't list it twice, you just write it once. Okay, so x is not allowed to be 0. Okay, step 3, reduce any common factors. Oops. Okay, so let me show you a common mistake to avoid. Right, so we see these like tempting x's right here, or these. These, remember, can only be reduced if they are factors, meaning they multiply the rest of their row. So like this x does multiply everything else, right? It touches the 2, there's a time sign, there's no pluses or minuses. But this x is not a factor. While it does multiply the 4, it doesn't multiply the 2. It gets subtracted by it instead. Okay, so we cannot reduce the x's because this x is not a factor. For the same reason, we cannot reduce these 2's. The bottom 2 is a factor, but the top 2 doesn't multiply the x, it subtracts it. Okay, so you can't do anything there. But what you could do is rewrite the 4 as 2 times 2. Okay, so now this 2 does multiply the rest of the row, and the bottom 2 also multiplies the rest. Okay, so you can reduce 1, 2 from each section. Okay, and even though there's no parentheses drawn here, this numerator is treated as like 1 unit. So I'm gonna go and put parentheses around it. Okay, so what we're left with in the numerator, we have 2 times parentheses x minus 2. And in the denominator, 5x squared times x cubed. That would be 5x to the 5th power. Okay, so this is fine. You can stop right here. I guess if you wanted to distribute out the numerator, you could, but this is good enough. Yeah. No, not unless I specifically tell you to. I would tell you if you need to. I think in general, leaving it in factored form is better because it's more useful for some purposes that we'll learn later in the unit. Yeah. Okay, so with those 2 examples in mind, go ahead and try part C and part D, please. So for this first one, x plus 3, it's already, again, 1x to the 1st power. You can't split it up, so just keep it the same. I will put parentheses around it because, again, each part of the fraction is like a unit. The 5 is just a monomial, keep it. Here I can do something, 5x plus 10, there's a GCF of 5. And then the 4 is just a monomial. Okay, so next step, remember, is to check for EVs. 5 cannot turn into 0. Doesn't matter what x is. And same thing, 4 cannot turn into 0. Again, it's not x plus 5. It's not 5x. It's just 5. Okay, so when there's no variable, there's no danger. Okay, so there's no excluded values. Okay, so now next step is to reduce. What color is that? Green. Okay, so 5 up here is a factor. It multiplies this parentheses, it multiplies that parentheses, and this 5 multiplies this. Okay, both 5s are factors, so we're allowed to reduce them away. Okay, you cannot reduce the 2 and the 4 because the 2 does not multiply the x, it gets added to it. Okay, so we're left with quantity x plus 3 times quantity x plus 2 all over 4. Okay, so again, some of you I saw multiplied this out. You got x squared plus 5x plus 6. That's fine, you could do that. I'll just leave it factored. Okay, and then over here, here we've got a lot of factoring to do. X squared minus 9 is a difference of perfect squares, x plus 3 over x minus 3. Denominator is a 1x to the 1st, but I'll just wrap it in parentheses. X plus 4, again, is already fully factored. But this one we can factor into x plus 6 times x minus 3. Okay, so for the excluded values, right, there's 3 different factors that could potentially turn into zeros. Okay, so x plus 4 leads to negative 4. X plus 6 leads to negative 6. And minus 3 leads to positive 3. Okay, so there's 3 excluded values for this problem. Sorry, don't forget to state the variable. Okay, now let's see what we can reduce. These x plus 4s, they do both multiply the rest of their rows. So we are allowed to reduce them away. The x minus 3s do multiply the rest of their rows, so we can also get rid of those. Okay, so now we're at x plus 3 over x plus 6. We cannot reduce anything else, right? These x's can't be reduced because they do not multiply the rest of their rows. The 3 and the 6 also can't reduce because, again, they are not factors of their own rows. Okay, so this is as simplified as it gets. Okay, so questions about either of these two? Okay, so let me jump down to letter F. So I know many of you didn't get a chance to look at this one yet, but we'll just look together. Okay, so this is a multiplication problem, even though you only see like one rational function. technically this is also a rational function because you could put it over 1. Okay, so start the same way as always, factor each part separately. 2 is just 2, 1 is just 1. But here we can maybe do some stuff with this. Okay, so those are pretty big numbers, but I do see that they're both even. They both end in an even digit, so I know I can factor out a 2. Okay, now I see that I'm left with a difference of cubes, right? This is 4x all cubed, and this is 3 cubed. Okay, so let me go down here. So don't forget the 2 in front, but now we've got 4x minus 3 times 4x squared, which is 16x squared, plus 4x times 3, so plus 12x, and then plus 3 squared, so plus 9. Okay, so again, I remember the difference of cubes formula, but if you can remember at least this part, you could then do, synthetic or long division to figure out the other term. Okay, so now the denominator, you've got 16x squared plus 12x plus 9. Can this be factored? Well, I already know the answer is no. How could you tell that? You could try the different combos. You also may remember the discriminant from maybe math 2, right? It's the inner part of the radical in the quadratic formula. So if you do b squared minus 4ac here, uh, 36 times. Okay, so the discriminant is negative. So that means that there is no real roots to this. Okay, so that means it can't be factored. Okay, so just leave it as it is then, because it can't be factored. Okay, so excluded values. This denominator is just a 1. There's no variable. This one, again, you could set it to equal 0 and try to solve, but that's the purpose of the discriminant, right? Sorry, I deleted this number. The fact that the discriminant is negative means that there's no roots to it. Okay, so again, this would be enough, but let me just show you to help you understand. If I did the full quadratic formula on this, okay, it would be, okay, x equals negative 12 plus or minus 12 squared minus 4 times 16 times 9 all over 2 times 16, right? But I already know that the b squared minus 4ac turns into a negative number, right? So when I plug negative 432 in the radical, it's not real. Okay, so again, that's a benefit of the discriminant. It lets you know a lot faster if there's real roots or not. Okay, so in this case, there's no real roots. Okay, so now reduce. So we do have these matching trinomials. Okay, they are both factors. They do both multiply the rest of their rows. Okay, so we are allowed to reduce them. Okay, so what are we left with? We're left with 2 times 2 is 4, and 4x minus 3. And the denominator is just 1, so we don't really need to write it. Okay, again, you can leave it here if you want. You can distribute it out to 16x minus 12. Okay, we're gonna skip part E. If it's something you want to do for practice, the answer will be on Canvas. Okay, let's go ahead and turn to the back, please. Okay, so we did multiplying, now for dividing. The good news is, just like we saw in the warm-up, right? The way we divide fractions is you turn it into multiplication. Okay, so we're gonna get to reuse most of the steps from earlier, right? We just gotta change the division to multiplication. Okay, but there is there are some things we need to be aware of. Okay, we're gonna start the same way though. Perfect, thank you. Okay, again, it's very tempting to want to jump straight into flipping things upside down or crossing stuff out, but you don't want to do that. You want to factor first. Okay, so just like on the multiplication steps, now that you have the denominators factored, check all denominators for excluded values. Okay, so then just like we do with regular fraction division, instead of dividing fractions, right, we rewrite as multiplication of the reciprocal, which again is the fancy word for the upside down fraction. Okay, so it's only the second function that you do the reciprocal. The first one stays how it is. Okay, so the next part, you need to check for EVs again. So what's the reason? Well, when you flip a fraction upside down, what used to be in the numerator is now in the denominator. So there's another potential source of EVs. Okay, after you've done that, reduce any common factors. Okay, and then the very last step is to multiply. Okay, so 4 of these 6 steps are the same as for multiplication, right? The only new ones are 3 and 4, right? So since it's division and not multiplication, you need to change it to multiplication. And then you need to do one more check for excluded values because there's a new denominator that wasn't there at the beginning of the problem. Okay, so let's start with letter B again first. Okay, step 1, factor each numerator and denominator separately. X plus 1, you can't do anything with it, but I'll go ahead and put parentheses. X squared minus 1 is a difference of perfect squares. Okay, so, sorry, that's not written correctly. Okay, so I'm keeping it as division for now. What happens a lot is students want to combine steps. They want to say, oh, I'll factor and flip it upside down at the same time. That leads to mistakes far more often than not. So please just go in order. Okay, this is already fully factored, but I'll go and put parentheses. Okay, and this trinomial over here x squared comes from x times x. This time the constant is positive. Okay, so the two signs have to match, but they it's either plus times plus or minus times minus. The middle is negative, so it must be a minus times a minus. Okay, and the only way to get to 1 is 1 times 1. Okay, so here's your factored form. Okay, second step, check for EVs. X plus 1. That leads to -1 as an excluded value. The factor of x minus 1. That leads to +1 as an excluded value. Okay, and over here, it's the exact same factor we had earlier. And same thing with this one. Okay, so you don't really need to check them. So -1 and 1 are the only excluded values. Okay, so let's remind ourselves, step 3, rewrite as multiplication of the reciprocal of the second function. Okay, so this first one will stay exactly the same. But instead of dividing by the second function, we will multiply by the reciprocal of this. Okay, so this x plus 1 that I'm highlighting, it used to be up here, right? So we didn't check it earlier. Okay, so we would want to check if this new denominator has any excluded values, but it's x plus 1. It's going to lead to -1 again. Okay, so in this problem, no excluded value, no new excluded value was created, but for some problems, there will be. Okay, moving on then, step 5, reduce any common factors. Okay, so this x plus 1 multiplies the rest of its row. Now we see 2 x plus 1s down here. It can only use up one of them. It can't cancel out both. Okay, so it doesn't matter whether you use it to cancel out this one or this one, but again, only one of them. Okay, so I'll just go diagonal, why not? Okay, so, right, this is a factor. Okay, so we can get rid of this and this. Okay, and then we also see x minus 1s. Again, there's only one in the denominator, so it can only take care of one of the two. It can't get rid of both. Okay, so we're left with x minus 1 in the numerator, x plus 1 in the denominator. Even though these both have x's, you can't reduce because this x doesn't multiply the 1, it gets subtracted by it. Okay, so since these are not factors, there's nothing more you can simplify. Okay, so this one is now completed. Okay, let's go back and do letter A now. Okay, so again, factor if possible. Well, all of these are monomials, so there's really nothing to do. Next, excluded values. Okay, you check 3, you check 9. Neither of those has any variables. Okay, so it seems like there's no excluded values. Okay, but let's continue. Next step is to rewrite as multiplication. Okay, so keep the first one the same, multiply by the reciprocal of the second one. Okay, and then now step 4, check the new denominator for EVs. So we haven't checked this 2n squared yet because it used to be in the numerator. Okay, so now when we set the 2n squared equal to 0, we do get an excluded value. Okay, so n is not allowed to equal 0. Okay, so just a quick warning though. Again, some people like to factor and flip at the same time. If you do that, you'll probably forget about this one, because if you jump to this step, this 9 that used to be in the denominator is now in the numerator, so you might forget to check it. For this problem, you'd be okay because 9 doesn't have any excluded values, but for other problems, you would miss it. Okay, so now we look to reduce. So these are all monomials. So the 9 could be rewritten as 3 times 3, so we get rid of a 3 from each section. The 8 is 2 times 4, get rid of a 2 from each section. And the n to the 5th and the n squared, you can, if you want, you can split up the n to the 5th as n squared times n cubed. So you can get rid of an n squared from each section. Okay, so in the end, you're left with 4 times n cubed times 3 would be 12n cubed. And there's nothing left in the denominator. Okay. Yeah, what's your question? All right. Yes, I would not reduce until after you have done the reciprocal. Yeah, so like looking ahead at letter C, it's tempting to try to like divide by 2 or something because you see these, but this is division, not multiplication. So yeah, the 10 is actually going to move up here. So the 10 and the 4m minus 8 are actually both parts of the numerator, not the denominator. Yeah. Okay, so let's give some time for everyone to try it out. Okay, so go ahead and start and continue. Once you finish C, move on to D, if you finish that, and so on. Okay, so for letter C, 4m minus 8 has a GCF of 4, so I'll factor that out. 5 is just a monomial, so I'll leave it the same. M minus 2, I'll just wrap in parentheses. Okay, so the initial denominators have no EVs. They're both constants. There's no variables. But now when I rewrite as multiplication, now I have a new denominator that wasn't there before. Okay, so now I'll set the m minus 2 equal to 0. And that shows me that m is not allowed to equal 2. Okay, and then these m minus 2s are factors. They do multiply the rest of their rows. So we can reduce those. And the 10, I'll rewrite as 5 times 2, so I can cancel out these 5s. Okay, so just 8. Letter D, so here you had to factor 4 different trinomials. So again, the more you practice, the better off you'll be. This first one, you got x times x is x squared. The last term is negative, so it's 1 positive, 1 negative. 14 is 2 times 7 or 1 times 14. The middle term is negative, so we want the bigger number to be negative. Over here, x squared is again x times x. Again, last term is negative, so 1 positive, 1 negative. This time the middle term is positive, so you want the positive number to be bigger. Here we've got a 2x squared, so it's got to be 2x times x. Last term is positive, but middle term is negative, so they're both minuses. Okay, and then here, both are positive, so it must be a plus and a plus. Okay, so the excluded values, especially for this problem, I want to make sure you guys make sure you got them all. Okay, so from here we've got a -6, right? I'll just skip ahead. Here we've got a +3. Here we've got a -2. Here we would have -6 again, so we don't need to write it. Okay, but now let's go ahead and do the multiplication by the reciprocal. Okay, so the new denominator that was initially in the numerator needs to be checked for EVs. 2x minus 7 leads to an EV of 7 over 2. Okay, and this x minus 3 would lead to positive 3 again. Okay, so you should have had 4 excluded values for this problem. Okay, so I'm guessing that some of you either had 7 halves or -2, but you're supposed to have both. Okay, again, you need to check the original denominator and the reciprocal denominator. Okay, so now for the reducing, the x plus 6s are both factors, so we're allowed to reduce those. You cannot reduce these x plus 2s because they are both in the numerator, right? So if you try to reduce back on the dividing step, right, the x plus 2s are diagonal, so it seems like you can reduce them. But after you do the reciprocal, they're on the same row. Okay, so again, I would not reduce while it's division. I would wait until it's multiplication. Okay, so nothing else is a common factor. So I'll just rewrite it with an exponent. Because you have x plus 2 times x plus 2, I'll say x plus 2 squared. And then over here, we have matching x minus 3s. It's, again, I would definitely not distribute this one out. I would stop right here. Okay, so again, please make sure you had all 4 excluded values. A very common mistake would be only having 3. Yeah. Both. Yeah, because any denominator at any point in the problem needs to be checked for EVs. Okay, so one last quick thing. I'm not going to fully do this problem, or let's just do this one. Okay, so when you've got this crazy looking fraction within a fraction, remember that fraction bar means divided by. So you could rewrite this as the top fraction divided by the bottom fraction. Okay, and then from there, it's just like the other problems.